Welcome class to the first materials explanation video. You will receive 6 videos in module 1 talking over each of the materials. We'll note that in this module, we have broken the materials down into 6 main categories. The first 2 categories are the wood and natural fibers category, the second category being the rock and mineral products category. These 2 categories are uncommon in most studies of materials, as they are not commonly looked at as engineered materials and so therefore are not heavily studied. However, understanding the basics of these materials does expand your knowledge and is more useful, as these materials occasionally do come up and are useful in developing and designing products. We should note that this video is a general overview of all 6 materials and will not constitute a specific coverage of any one material. To begin with, we'll look at the woods and natural fibers. The woods and natural fibers as a group are mainly consisting of plant-based grown objects. We should note that there are exceptions to this, as other natural fibers such as asbestos, which is a glass fiber, do exist. However, we will focus mainly on the plant-based fibers for this group. You can look out and find examples of synthetic fibers as well. We will not include them in this group either. The main advantage of the woods and natural fibers have to do with their versatility and their use. Woods and natural fibers provide tensile strength in abundance. They are usually quite compressive, and they have a variety of strengths depending on the material. We'll tend to classify them based on what they are from. So for example, the woods we will tend to classify into softwood, that is evergreen type trees and brush that grow continuously, and hardwoods, that is deciduous type trees and brush that grow in cycles and lose their leaves each year. Although the name soft and hardwood would indicate that some are stronger or more impact resistant than others, this is a misnomer in some ways, as a common hardwood balsa wood is softer than a common softwood cedar. So we should note that do not depend upon the name hardwood or softwood to indicate the overall strength of the material, but rather to tell you the approximate type of wood that it comes from. If you want to know more about the specific types of woods and materials, I recommend looking them up online and reading through your textbook so you can develop a good definition of the woods. Your natural fibers. Natural fibers as a group consist of fibers that are produced either from animal or plant products. Common animal-based products include things such as wool. Many animal-based products are protein-based, meaning you have a polypeptide of proteins that reduce down into a strand. These strands can then be used together. Plant-based fibers also exist. Many plant-based fibers are, instead of being combined and stretched, are instead rendered down to their most basic components, for example, wood pulp. We should also note there are other sources of naturally occurring fiber, such as chitinous material, which is a recurring polypeptide, once again, this time of sugars. Although you would think sugar is weaker than protein, it turns out that chitin is much stronger than wool, so you could be surprised. Get to know your materials, research them, you'll find out a lot about them. Next, we're going to look at the rocks and mineral products. Rocks and mineral products are mainly defined by how they're acquired. That is, they are mined or dug up. Although, on the whole, rocks and mineral products are not consistently seen as an engineered product, you should note that many engineered products are based upon mineral products. So therefore, an engineered countertop, which is something you can buy for your house, is based on either glass or quartz or some other similar mineral product that is then combined, compressed, and made into the final product. So it takes the overall advantages of whatever mineral was utilized in making it. Similarly, you can use a rock-based product. So I can buy a nice piece of marble, have it cut down to the correct dimensions for my countertop and installed. Here we are dealing with a rock. A rock is going to have similar mineral abilities as its mineral product. However, because it is not a processed product, it's also going to have natural occurring defects within the product. So for example, if you ever look at a true marble slab, you'll find that marble slabs often do contain tiny fissures that run through the material. Past this, we run into 4 categories that are clearly both impacted by man and developed by man to improve their abilities. I'm going to go ahead and share my screen with you. Here we have the metals, polymers, and ceramics and glass and composites. We're going to jump onto a website. This is nde-ed.org, and what they have inside of here is a whole sections on materials and processes, which allows you to understand these 4 materials in greater depth. This is not a required resource for this class, but it is recommended reading as it does cover in great detail what separates these materials. So for example, when you look at the metals, there are 2 core types of metals we care about: ferric and non-ferric materials. Ferric materials usually contain amounts of iron that allow them to be easily magnetized. Non-ferrous materials usually are based in materials such as aluminum, copper, or magnesium, although nickel and titanium are also included. Key difference between these 2 materials is the presence or absence of iron. Iron is a very interesting material in development of metals, as it requires us to get it from ore, process it, but then it's magnetic when it's done. Many of the other metals that we process and develop are not magnetic, and therefore ferric. Polymers. Polymers, also known as plastics, come in 3 main categories. Thermoplastic. Thermoplastics are plastics that when heated begin to soften. These are most plastics that you are used to, however not all. Thermosets. Thermosets are plastics that are liquids until they are mixed, and then they set into a hard final solid that is not able to be remelted. Thermosets go through a chemical reaction in their formation and are set in their ways after they're done. Think epoxy on this one. And finally, elastomers. Elastomers are usually thermoplastic in nature, although not always, but they share the commonality that they are soft or rubber-like after their formation. So for example, vulcanized rubber used in tires is an elastomer. The next category is ceramics. Ceramics is a process category. Usually it's going to be glass. It's the most common example of ceramic that we utilize, and there's a lot that we do with glass. Go ahead and look at some of the extra glass videos down below to get some ideas. You can also have things such as diamond and graphite, which are technically ceramics. You also get into composite ceramics, ceramics that allow for extra materials to be mixed in. We're going to include those in the final category, composites. Composites is a very broad category. Basically, composite says, I'm taking material from one of these other 5 categories and mixing it with another material from one of these 5 categories. For example, I can be mixing 2 ceramics. I could be mixing a ceramic and a metal. Or I could be mixing a plastic and a natural fiber. Each one of these is a unique and completely different composite. The composites take a few different types. Reinforcement. Reinforcement of material is quite common, especially in the plastics. Metal matrix or ceramic matrix. A pre-existing, usually honeycomb material is filled in with some sort of other material. Sandwich structures. Multiple materials are layered over each other and then compressed or combined into a final material. Or finally, slurry mix. Example, concrete. Multiple materials are slurried together, then allowed to solidify into a final product, usually during which some sort of chemical reaction occurs that yields the final product different in some material way. I hope this video helps you identify the 6 core materials and helps you begin your live notes for this week. Have a great day.